Hey there everyone, today we've got half angle identities. This is going to be the second part of section 5.5.1. So if you want to head your notes, this would be 5.5.2, 5.5 day 2. And we're learning our half angle identities. Now, fortunate for you guys, I'm not going to require you to memorize these. So these will be provided for you on any tests or quizzes that we take. But it is important that you know how to use them. And generally, they're kind of only useful in specific cases. For example, our first problem wants to find the exact value of this really peculiar angle, 112.5 degrees. Well, we're kind of fortunate because 112.5 degrees happens to be exactly half of one of our angles on our unit circle. So all of these half angle problems are going to always be looking for angles that are half of what's on your unit circle. So the first thing you want to do is you want to take cosine of 112.5 degrees and rewrite that as half of, let's see, 112.5, if I double it, would be 225. It's half of 225 degrees. So I can rewrite this as 225 degrees divided by 2. Okay? So once you have it written as a half angle, basically any angle being cut in half, we can use our identities up here to get the exact value for it. So as I look up here, cosine of an angle divided by 2 is equal to plus or minus the square root of 1 plus cosine of theta. Now, theta is not 112.5. Theta is the angle that we just cut in half, which was 225. So that's what I'm going to put right in here. I'll put that in blue. So 225 degrees goes in there. And then we're going to divide that by 2. So now we can look on our unit circle and we see that the cosine of 225 degrees is exactly square root of 2 over 2. Negative square root of 2 over 2. So this is plus or minus the square root of 1 minus the square root of 2 over 2, all divided by 2. And so this next part, if we want to try to simplify this any further, we can divide both the 1 and the square root of 2 over 2 by 2. So 1 divided by 2 is equal to 1 half. So this becomes the square root of 1 half minus square root of 2 over 2 divided by 2 is square root of 2 over 4. And then we can combine these fractions. There's going to be plus or minus the square root of 2 over 4 minus square root of 2 over 4. So we get common denominators, so we can combine these. Move those out of the way. And then when we combine them, we get plus or minus the square root of 2 minus the square root of 2 all over 4. And you should notice that this is a perfect square in the denominator, so it'll actually simplify if I take the square root of the top and the square root of the bottom. So the last thing we get, and this is a little funky, it's the square root of 2 minus the square root of 2, that's just my top, and then the square root of 4 in the bottom is 2. Okay, now the plus or minus is there to remind us that we need to check to see what quadrant we're in. We are still technically taking the cosine of this angle, which is in my second quadrant. Right, it's more than 90, it's less than 180, and because I'm in my second quadrant, cosine is always negative in that quadrant, so we should just use the negative solution. Okay, and so that's your exact value for the cosine of 112.5 degrees. It's the square root of the quantity, 2 minus root 2, all divided by 2, negative. Okay, so I have two more problems down here for you to try on your own. The sine of 75 degrees and the tangent of 7 pi over 12. Now we already talked about how to find the exact values of these using your sum and difference, if you could break them down into the sum of two angles or the difference between two angles. But since this lesson is on using half angles, let's use the half angle identities instead. 75 degrees happens to be half of 150. So I'll get you started. We're going to write this as the sine of 150 degrees divided by 2. And 7 pi over 12, that just happens to be half of 14 pi over 12. So I could write this as 14 pi over 12 divided by 2. If you're uncomfortable with the fractions like that, you can always change it to degrees and solve it that way. But remember, to get this, all I did was I just doubled the numerator. That's how I got 14 pi over 12 divided by 2. Okay, so try these out on your own. Okay, here are the solutions to the problems. Sine was pretty straightforward. You found the value of cosine of 150 should have been square root of 3 over 2. You're subtracting a negative. Remember, that was negative square root of 3 over 2 because you're in the second quadrant for cosine. And then make sure you distribute the 2 to both, so you get 1/2 plus square root of 3 over 4. You're subtracting a negative, so it becomes a positive. And then get common denominators and simplify just like we did in the first example. For the second one, you had a couple of options. You could have used any of the 3 half-angle identities for tangent. I just chose sine of theta all over 1 plus cosine of theta. So I plugged in, reduced 14 pi over 12. Remember, that was when we doubled this angle to get its solve for its half. We got 14 pi over 12 is really 7 pi over 6. And that's the part that's on our unit circle, so that's the one we want to plug in. So sine of 7 pi over 6 and cosine of 7 pi over 6. There's quite a bit of simplification here. Basically, you're just trying to combine the fractions, and then when you get a binomial with a radical in it in the denominator, just multiply by the conjugate, which is what I did here, and we get 2 plus the square root of 3 at the end. Okay, our last application for half-angle identities is going to be using them to solve an equation. So anytime you see an equation with x over 2 or theta over 2 in it, you know you're going to want to change that to a regular trig function by using your half-angle identity. So starting with this problem, sine squared x equals 2 cosine squared of x over 2. I know that I can go ahead and change the cosine of x over 2 using my identity. So this is really equal to 2 times plus or minus the square root of 1 plus cosine theta, or cosine x in this problem, divided by 2. And we're squaring that. Remember, this is cosine squared, so we want to make sure we square our identity when we get to here. Okay, and it's just set equal to sine squared of x. So luckily, when I square a plus or minus, the plus or minus goes away, and so does the radical, so this just becomes 2 times 1 plus cosine x, all divided by 2. And so we can multiply cosine of x plus 1 by 2 and then divide it by 2, but really those are going to cancel out. And so we're just left with 1 plus cosine x on the right side and sine squared of x on the left. So I have a sine and a cosine function. I need to use my Pythagorean identity to change sine squared into 1 minus cosine squared. Now that all of my trig functions are the same, they're all in terms of cosine, I can set one side equal to 0 and factor. So I'm going to go ahead and just add the cosine squared over and subtract the 1. This should look familiar to other types of equation problems we've solved at this point. So I'm left with 0 on the left side, the 1's cancel, and I have cosine squared x plus cosine x. And now I can look between these two and see that I can factor a cosine out. Don't be tempted to cancel the cosine out, you want to factor it. So I'll continue up here. This is 0 equals 1 cosine factored outside, leaves inside 1 cosine of x plus 1. And now we just set each of the factors equal to 0. So when cosine of x equals 0, and when cosine of x plus 1 equals 0. So we're looking for where cosine is equal to 0, which would be at pi over 2 and 3 pi over 2, and where cosine of x is equal to negative 1, which would be at pi. And those are our solutions. Okay. We're going to ignore 6b for this lesson. You can just attempt 6a for practice now. Okay, so this one wasn't too bad. When you did your substitution for sine of x over 2, you should have gotten plus or minus the square root of 1 minus cosine x over 2. The square that you have to do, make sure you keep the squared sign in there. You're going to have to square your identity. When you square the identity, it cancels out the square root and the plus or minus. And because we had 2 for our coefficient, that's going to cancel out the 2 in the denominator here. So really quickly we can see that we're just left with 1 minus cosine x, and that's what I have written right here in red, the 1 minus cosine x. Then we have to add cosine x to that and set it equal to 1 plus sine x, the rest of the equation. The cosines cancel. When we subtract the 1 over, we get 0 left on the left side is equal to just sine of x is the only thing left on the right side. And we have a pretty easy equation there. Just find out when sine is 0, that's at 0 and pi. Okay, that's it for this lesson. We will be doing more problems like this in class. Have a great night.